Hi guys, so we are still looking at database technology, but here we proceed by looking at the data modes. So here we proceed by looking at the data mode in database technology. So when you talk of the data modes are fundamental concepts in the field of data management and database design. So they are fundamental concepts in the field of database management and database design. They provide a structured way to represent and organize data. So in order to organize the data, there should be an aspect of the data mode. So this is the reason why we are saying that they provide a structured ways to represent and organize data in a way that is both efficient for storage, retrieval, and comprehensible to human. So because of the data mode, we are saying that they organize data in a way for efficient retrieval, storage, and comprehensible to a human. So there are different types of data modes of which we are going to look at them one by one, but the most important part is that you should understand that the data mode, they organize data in a way that is both efficient for storage and retrieval and comprehensible for human. Okay, so let us proceed by looking at the modes. So let us proceed by looking at what is a data mode. So we proceed by looking at what is a data mode. So looking at a data mode, so we are saying that a data mode is a formal representation of data. So a data mode is a formal representation of data along with the structure and relationship between data elements. It serves as a blueprint for how data is stored, accessed, and manipulated. So again, we are saying that here we are looking at data. What is a data mode? So what is a data mode? So here we're saying that data mode is a formal representation of data. It is just a formal representation of data along with the structure and relationship between data elements. It serves as a blueprint for how data is stored, accessed, and manipulated. So the way data is accessed and manipulated is as a result of the data mode. Okay, now let us proceed by looking at the types of data mode. So we proceed by looking at the types of data mode. So we have the conceptual data mode. So we have the conceptual data mode. So under the conceptual data mode, a high-level abstract representation of data, a high-level abstract representation of data. Abstract can be something that you cannot see, but they are very much important in any field of work. So abstract can be something that you cannot see, but they exist and they are very much important in the aspect of any work or project. Yes. So conceptual data mode, a high-level abstract representation of the data, focusing on entities, attributes, and their relationship. So often using during the initial phase. So it is mostly used during the initial phase. So at the beginning of database design to define the overall structure of the data. So if you want to define the overall structure of the data, that's where now you use the conceptual data mode, which include high-level and abstract representation of the data. Like I've said, the abstract can be something that you cannot see, within, but they are very much important on the operation of the database. So the first thing on the database is the conceptual data mode, which define the overall structure of the data. And then apart from that, we have the logical data mode. We have the logical data mode. So under the logical data mode, a more detailed representation that defines data element. So this one, logical data mode, actually represents and define the data elements. So it defines the elements that are used in the database, their attributes and the relationship between them. So independence of any specific data management system. So independency of any specific database management system. So we're saying that a logical data mode, a more detailed representation that defines data elements. So this one is more details on the representation of the database, and it defines elements, their attributes and the relationship between them, independence of any specific data management system, which is a database management system, which is DBMS. Okay, and then we also have the aspect of physical data mode. We also have the aspect of physical data mode. So the physical data mode specifies how data is actually stored in database. So we are saying that the physical data mode specifies how data is actually stored in database, including file structure. So this includes file structure, indexing mechanism, and storage allocation tied to a specific database management system, and takes into an account performance and storage. Okay. And then we also have the key concepts. So we have the key concepts. So we also have the key concepts. So under the key concepts, we have entities. So we also have the key concepts. So under the key concepts, we have entities, we have attributes, we have relationships, we have constraints. So under the key concept, we have the entities. Now, when you talk of the entities here, the entities emphasize on objects or concepts. So we are saying that the key concept here, we have got entities. So now the entities focuses on objects or concepts in the real world that are present. So they focus on object and concepts in the real world that are represented in the data mode. So these focuses on the concept and objects that are in the real world, and they are presented in the data mode. Examples include customers. Okay, so examples of the entities can be customers, products, and employees. So examples of the entities, like we are saying, that the entities focuses on objectives and concepts in the real world that are represented in the data mode. So examples of the entities are customers, product, and employees. Okay, and then under the key concept, we also have attributes. Under the key concepts, we also have attributes. So when you talk of attributes, properties or characteristics of entities defining the data that can be stored about each entity. So for a customer entity, attributes might include name, address, and phone number. So when you talk of the attribute, remember we're talking about the entities, and the examples of the entities can be customers, product, and employees. But when you talk of the attributes, examples of the attributes can be the customer name, can be the customer address, and the phone number. So all these symbolize the attributes. So we're saying that attributes focuses on the properties or characteristics of entities, defining the data that can be stored about each entity for a customer. So entities attributes may include name, address, and the phone number. So when you talk of the entities, the entity example is the customer, but when you talk of the attribute can be the name of the customer, can be also the address of the customer, and can also be the phone number of the customer. So apart from the attribute, we also have a relationship. So remember, still looking at the key concept. So we're still looking at the key concept. So we continue by looking at the relationship. Now, when you talk of the relationships, association between entities that describes how they are connected or interact with each other. Types of relationship includes one-to-one, one-to-many, and many-to-many. Okay, so here the relationship association between entities that describes, so remember entities can be the customer, can be the entities can be customers, can be products, can be employees. Okay, so now here it focuses on the association between the entities. So this association between the entities can be types of relationship that can exist between one-to-one, one-to-many, and many-to-many. That is just the relationship. And then we also have the aspect of the constraints. So we are still looking at the key concept. So now we have the constraints. So we have talked about the entities, we have talked about the attributes, we have talked about the relationship, and we have talked about now the constraints, which is also part of the key concept. Now, when you talk of the constraints here, rules and restrictions placed on the data mode to ensure data integrity and accuracy. Example includes unique constraints, differential integrity, and check constraints. So here, we focus on the rules and restrictions placed on the data mode to ensure integrity and accuracy. For example, include unique constraints, differential integrity, and check constraints. Okay, so thereafter, and then we now proceed by looking at there are a lot of flies here, guys. I don't know why there are a lot of flies, but it's all over. Yeah, definitely. Okay, so now we proceed by looking at the data mode notation. So we proceed by looking at the data mode notation, which is entity relationship diagram, So these entity relationship diagram uses symbols like rectangle for entities. Okay, so we are saying that these entity relationship diagram uses symbols like rectangle for entities, diamond for relationship, and oval for attributes. Okay, so it uses symbols like rectangle for entities, diamond for relationship, and oval for attributes. Okay, so yeah, so visually it presents the structure of data and the relationship between entities. That's how it operates. And then we also have unified modeling language, UML. We also have the aspect of unified modeling language, which is UML. So here, while it is widely used in software engineering, so when you talk of unified modeling language, it is widely used in software engineering for the easy communication of the entities. Okay, so unified modeling language it is widely used in software engineering. Unified modeling language diagrams can be adapted for data modeling. So includes classification diagrams to represent data structure. So if you want to represent the data structure, you can also use the language which is a unified modeling language. Okay. And then now, apart from that, we continue with the aspect of advantages of data mode. So here we are looking at the merits. We are looking at the merits of data mode. We are looking at the merits of data mode. So under the merits of the data mode, the first one is clarity. So the first one under the advantages of data mode is clarity. So under clarity, we are saying that data modes provide a clear, structured representation of data, making it easier to understand and communicate. So data mode makes it easier to understand and to communicate. So the first advantage of data mode is clarity. So clarity brings the aspect of easier understanding and communication. So here we're saying that data mode provide a clear, structured representation of data and making it easier to understand and communicate. So it is very much easy to understand the representation of data and easy to communicate because of the clarity. So the data mode brings the aspect of clarity. Okay, and then there is also another advantage of data mode, which is consistency. So there is also an aspect of consistency in data mode. So here we are saying that data mode help in maintaining. So it helps to maintain data integrity and consistency before enforcing a constraint. So before enforcing a constraint, the data mode, they help to maintain data integrity. So this brings the aspect of consistency. So apart from the aspect of consistency, there is also a point which is one of the advantages, which is scalability. Now, when you talk of the issue of scalability, here we are saying that a well-designed data mode can scale as the data and application requirement evolves. So it can scale. So we're looking at scalability. So it can scale. It is able to evolve. It is able to change and adapt to the growing data. That's what it means on the scalability as one of the advantages of data mode. And then apart from that, we also have the point of the aspect of efficiency. So under efficiency, which is one of the advantages of data mode, here we are saying that properly designed data mode can improve data retrieval and manipulation performance. So here on the efficiency, we are saying that a well-designed data mode can improve data retrieval and manipulation performance, which is part of the efficiency. Okay. Now, apart from that, let us proceed by looking at data. Let us proceed by looking at common data mode. So here we're looking at common data mode approaches. So we're looking at common data mode approaches. So under the common data approaches, here we start by looking at Lachonel data mode. Here we continue by looking at Lachonel data mode. So under Lachonel data mode, here we organize data into tables with laws. Okay, so here you organize under Lachonel data mode. Here you organize data in tables with rows and columns. Okay, so with rows and columns, and then also rely on primary keys, okay, to uniquely identify records and foreign keys to establish relationship. So here we're emphasizing on organizing the tables, the data into tables with rows and columns. And then there's also an aspect of NoSQL. There's also an aspect of NoSQL data mode. So this one focuses on diverse range of mode, including documents, key values, column family, and graph database. So designed to handle unstructured or semi-structured data and can be more flexible than Lachonel database. Okay. Apart from that, we also have an aspect of data modeling tools. So we also have an aspect of data modeling tools. So here, the data modeling tools mainly focuses on various software. So the data modeling tools, it mainly focuses on various software tools are available to assist in creating and maintaining data mode. So this can include entity relationship diagram tools. It can also include unified modeling language tools and also database design software. Okay, and then we also have the aspect of data modeling best practices. So here we look at data modeling best practices. So under data modeling best practices here, it mainly focuses or it mainly involves stakeholders to understand requirements. So here on data modeling best practices, here it ensures that the stakeholders should be able to understand the requirement. very important here. So the stakeholder should be able to understand the requirement and then also maintain a balance between normalization and normalization. So it should be able to maintain the data redundancy and also minimize duplication, which is the normalization. And then there is also an aspect of ensure data mode are adaptable and extensible. And then we have document the data mode thoroughly, and then regularly review and update the data mode in reflect with changes in business requirements. Apart from that, there is also an aspect of challenges in data modeling. There is also an aspect of challenges. There is also an aspect of challenges in data modeling. So here, it focuses on data modeling can be complex. So on challenges, so when you talk of challenges in data modeling, here we are emphasizing on data modeling can be complex, and challenges may include managing data sets, handling data variability, and accommodating evolving business needs. Okay, so yeah. So here under challenges in data mode, here we are saying that data modeling can be complex, and the challenges may include managing large data sets, handling data variability, and accommodating evolving business needs, okay, which is very much important, and it is part of the data modeling. Very important. And then apart from that, in conclusion, we are saying that data modes are crucial for designing and maintaining database, ensuring data is structured, organized, and accessible in a meaningful way. And the other point is that they inform the foundation for effective data management and application development. So this is just part of data modeling, which is very much important in database management system. Hope you have enjoyed the video. Don't forget to watch the next video, and remember, just like university, we are there to deliver the quality education. I wish you all the best, ladies and gentlemen. Thank you very much, and thank you for your time. Thank you.